Hey there, and welcome to Into the Terminal episode 33. My name is Eric the IT Guy Hendricks, and joining me every episode is my partner in crime, Mr. Scott McBrien. Way to blow the intro there.
Thanks, Eric.
It's that guy, or that guy, depending on where you're leaning. All right. With that said, no fancy intro after that. So you may recall way back when in episode 3, so 30 episodes ago, we talked about installing packages. So we used DNF, Yum to interact with repositories, pull down like web servers, and install all the things to use on our systems. So we're going to do a little bit deeper dive into that topic today, and we're going to talk about the RPM command. So before we dive in deep into what the RPM, why you choose DNF versus RPM, uh, let's dive in and let's see what the RPM command is about. So uh, so why don't we first start off with an easy one? In episode 3, one of the first things we talked about was how to see what packages were installed, and you do that with a DNF list installed. So Scott, on the RPM side, there's a way to do this as well.
Actually, DNF and Yum sit on top of RPM. So RPM is actually doing a lot of the package management-y things behind the scenes. And so a lot of the features that Yum and DNF provide are also things that are natively in RPM. So if you wanted to see what was available in the system, you do an RPM query for all packages, and it'll give you a list of all the packages installed on the system.
We could actually tie that into what a WC-L to see how many packages are actually installed in our system.
Yeah, we certainly could. So we could just pipe that into WCL. There you go. So this machine has 594 RPM packages installed.
So we don't want to look at all the packages. Why don't we look into a particular package? One that comes to mind is the web server, so HTTPD.
All right, so we could do an RPM-Q HTTPD, and it'll just tell us the name and version and architecture that we have. But there's a bunch of additional queries that one could launch against a specific package. For example, maybe you want to know what was provided when you installed HTTPD. So if we do an RPM query to list the files with this package, these are all of the files that were provided. And then as an RPM packager, you can choose to flag certain types of files. So maybe you're interested in being a system administrator and you want to know what the configuration files for this package are. So if you do a QLC to query for a list of configuration files, these are the ones that were provided as part of this package. And this configuration file flag is something that's placed there by the developer who compiles this RPM. Maybe you wanted to find out more about using Apache. So QLD will query for a list of documentation flagged files. So these are the documentation files provided by this RPM.
So the thing to remember is RPM-Q is a query, and then you can add additional arguments onto that, whether you want to do whether you want to look at configuration files or dependencies. We can also do sort of the reverse of that. So if we wanted to see what package we're interacting with when we're looking at a particular file, we could pick a packet, or we could pick a file pretty much at random and do almost a reverse lookup. So if we did an RPM-QF, we can actually so query files. We could do something like nfs.conf, which I believe is on this system. Oh,
Nope.
it's not. Interesting.
How about you pick one
Um,
off the screen, Eric?
I could do that. About let's do locale.conf. So that has to do with language and locale. So and location. So let's do locale.conf. So we
And
can
so
see. Go ahead.
Etsy locale.conf is provided by the system DRPM.
There we go. All right. So sorry, nfs.conf, to answer the question in the chat, is the configuration file for network file system, NFS. So that's not installed on this system. Strangely enough, my vanilla RHEL 9 machine here in my home lab picked it up because I thought I was being clever, and it turned out to be a case of it works on my machine, but didn't work on Scott's. But we can do anyway. We can do a -qf, which is query file, and on just about any configuration file, and we can figure out what package it came from. In this case, in this case, we see that it's part of the systemd package. So we can also do a -v option. Scott, you want to talk us through what -v does?
Sure. So a -V is a verify. So we know that every package stores the list of files that came from it. And we can either see that list by querying the package out of the database, or we can query based off the file and find out what package provided it. But it turns out that we also store a whole bunch of metadata about all these files. So if I do an RPM-V to verify a package, and I'm just going to use OpenSSH server, what we get back is the list of files that have been changed since this package was installed. And not only are we told that these files have changed, we're actually told some about the properties of these files that have changed. So you'll notice on the left-hand side of the output, there's a series of ASCII characters. And the first, 8 or so are properties of the file. So looking at etc ssh dconfig, we can see that the size of this file has changed since it was installed. The MD5 checksum of this file has changed, meaning the content has changed, and the last modified timestamp on the file has changed. The other properties that we track are unchanged. That's why their positions are represented by periods. Additionally, we can see that this file has been flagged by the RPM developer as a configuration file. And so I looked at it and I'm like, okay, so somebody went into this configuration file and made a configuration change. That's not unusual. But if we were to look at something like a binary file, and we see that its size, checksum, and timestamp have been modified, that like makes the hairs on the back of my neck stand up pretty readily. We can also do something like an RPM, just to see another example, RPM-V setup. So this one, a couple of the files have changed. We see some additional properties that we didn't see earlier. So Etsy profile was changed in the same way: size, MD5 checksum, last modified timestamp. Varlog last log, however, size is the same as when it was installed, but its mode, its permissions have changed since it was installed. Its content has not changed. A couple more parameters have not changed. And then the group owner of this file has changed since it was installed. And then we can see that this is tagged as a G, and we'll have to actually look at the man page to figure out what that means. So if you're interested in figuring out the key to deciphering this, if you take a look at the man page for RPM, and you go down to the verify section, notice that you can exempt certain things from showing up in your verify. But if we go down far enough, I will see that there's some tags. So I said that C was a config. G was what we saw with the last log. It claims that this is a ghost file. Would have to do a little more research for me to understand what that means, because I don't want it haunting my system. And then a little bit further down, there are what you would see in each one of those positions where we track a parameter about this file, right? So size, permissions, MD5 checksum, the device on which it resides. It is a link that has been changed, user owner, group owner, last modified time, or capabilities. And again, we'd have to probably look at see what capabilities means. I would guess it's something like ACLs or some other extended attribute of the file.
Right. Let's see. All right, why don't we transition over to our deeper dive, and we'll address a couple of questions in the chat, and we'll look at what else we can do with RPM. So the next thing we wanted to cover was sort of use case. When so funny enough, there's a couple of questions going around in chat, and I know exactly how to answer these questions if it were DNF based or Yum based. But I'm not exactly sure how that would work with RPM. So why don't we start with a high level question of when would we want to use RPM versus a DNF command?
So I mentioned that RPM is like the basis for the actual package mechanics that DNF or Yum manage. The big difference is that RPM has been with the Red Hat distribution since before Red Hat Enterprise Linux. Right, so all the commands that we just looked at, like you can run these on any Red Hat Enterprise Linux system, and it will produce a similar output. But the reason that we now use Yum and DNF is because there's a whole bunch of additional things that we used to struggle with back in the day that Yum and DNF solve for us. So, for example, package dependencies is a big one. How do I get packages onto my system is another big one. So when we talked about managing packages before, one of the things we looked at was creating a repository and a repository definition. So Yum doesn't work off of a repository or a repository definition. It expects to work with individual RPM packages. So if you want to install a package, you have to tell it the package name and the file. Or you might be able to, any reasonably modern Red Hat Enterprise Linux, you could also provide a URL to it for HTTP or FTP, and it could actually download that file and then transact on it. But it's expecting an individual file. And so the real thing that DNF and Yum provide is the ability to manage all those dependencies, and the fact that to install this thing, I need to also have this variety of other supporting packages that we need. So being able to call to multiple repositories to find it across different places, like all that stuff is so much better with Yum and DNF. In fact, it's not provided at all by RPM natively. So that's why we use Yum and DNF. And I would say that for the person who hasn't had to like delve deep into packaging, that's where you should go. You should stick with Yum and DNF. But these are things that one might be interested in if they were doing something like troubleshooting on a system.
Yeah, to be honest, in a lot of areas, I'm kind of part of the elder generation of sysadmins, but there's definitely more the system operators where there's just certain tools I didn't use much, and beyond RPM-QA, most of the time I just used Yum and nowadays DNF. And in fact, Shantanu was talking about having nightmares about running with UpToDate, and I mean even that was kind of an early generation package manager wrapper that went around RPM. So I can definitely relate. I've had to custom compile packages, but for the most part, I've had Yum or DNF at my disposal the whole time. So with that in mind, we had a question that came in over chat about using RPM to do to figure out what. So my example was NFS, which wasn't installed on our lab system for today. And so using my default would be DNF what provides, and then I could type in nfs.conf, and it would tell me what package I need to install. Is there an RPM equivalent to DNF what provides?
So kind of, but no. So the problem that you have is that nfs.conf does not exist on this machine. So that means that the RPM database on this machine doesn't have a record of that file. So there's nothing for it to query against. Whereas like DNF and Yum would go out to their configured repositories and look at the file manifests of all the files provided by those repositories and be able to answer that query for you. So you could I think you could probably do a local query, but like trying to figure out why that file's not there and what you could get to get that file, that's not what you want to use RPM for. All right, again, like DNF and Yum are superior in this use case. But
Fair
one of
enough.
the things that might be interesting is to see like what other packages need this package, right? So let's say we were considering removing HTTPD, and we did rpm-q what requires HTTPD. And so what we're looking at is the list of installed packages on the system that if we were to remove HTTPD would be broken, right? And again, like Yum and DNF fix this for us. If we remove HTTPD, it would add these to the package transaction because removing HTTPD would break them. And if we try to do this natively with RPM, it would fail and error and say, we can't do this because these other packages say they need this package. So you could see like what the dependencies are. In fact, like this data is what's used by Yum and DNF to do their package transactions.
So we kind of drug RPM through the mud there with our NFS example. So why don't we talk about a few use cases where RPM really shines, and that's make sure I don't skip too far down our list here and throw Scott off, but not that I've ever done that before. But one of the nice things about using RPM is you can actually generate some scripting around RPM. So we sticking with Apache with HTTPD. What can we use RPM to? Where does RPM really shine versus say a DNF?
Well, so again, I don't think it's a versus, right? Like RPM is what's used by DNF. So DNF wraps a lot of the difficult things like dependencies that that RPM has traditionally struggled with to fix that stuff. But a lot of the things that we look at with DNF, like DNF info, actually come from RPM, right? So if we do a RPM-QI, query for information, in a package, here's the information that we get from it, right? We get the name, the version, the release, the architecture is built on, when it was installed on this machine, and then we get a little bit more data as well. And if I know that there are a couple of RPM packagers watching the live broadcast, they would recognize this from the file they put together when building RPMs called a spec file. So it grabs that data that the RPM builder provides and makes this little summary information page out of it. Also, one of the things that you can do when you're building an RPM is you can put in scripting. So when we're installing a package, maybe we need to ensure that something is a certain state on the machine, right? Maybe we need to make sure that a file exists or a directory location, or that something is permissioned in a specific way, or a whole variety of things. Or maybe we need to do things after our software is installed to like fix it up to be used by the system. So we can do an rpm-q scripts. And I'll go ahead and just send that to Les. And so there are several different types of scripts that one can use. There's the pre-install, which we don't see here, a post-install, a pre-uninstall, and a post-uninstall. And then there's a couple of newer ones that are pre-trans and post-trans, which are before the RPM transaction takes place or after the RPM transaction takes place. And so for here, for Apache, we can see that after we install the Apache RPM, right? So after we've flung all the files around in our directory tree, we then do this thing called user lib systemd update helper, where it installs the systemd units. So as part of the RPM installation, we placed the HTTPD service file in the systemd directories, and we placed the HT cache clean service and HTTPD socket files in the systemd directory. But we then need to register those with systemd so systemd knows about them. And so that's what this update helper is doing, is installing these units in systemd so that systemd now is aware that these additional service or management control units are available to it. Right, and then for pre-uninstall, right? So this is, we're going to delete this from our machine. We kind of do the opposite, right? So if we told systemd that all those new units were available for it to use, then if we're going to delete them from the system, we probably need to remove them from systemd so that it doesn't try to use them anymore. And so that's what the systemd update helper remove system units does. And notice it's the same list. So when the packager is putting together this RPM, they decide like what needs to happen on the machine to either prepare it for the software, to manage things after the software has been created, or if we're going to delete the software, what things do we need to do to the system before deleting or after deleting the software?
So I could
Right. So,
imagine pulling in. I'm sorry, go ahead.
oh, after you.
So I could imagine pulling in an update to a package, say HTTPD, and maybe some variable that I was working with, maybe some like a virtual host functionality changed within the package, and then something that I'd set up for my website doesn't work anymore. One of the areas that RPM does do very well is in communicating changes to individual packages. So we kind of looked at some of the information that came from a spec file that actually goes into packaging the RPMs. But included along with those is anytime a patch is attributed to a package and you install that, there's usually a change log that comes along with it. So the RPM command actually gives us the ability to look at that change log.
Yeah, so if we do an RPM-Q to query the database for the change log associated with the package, you can get a list of the changes. Now, keep in mind, this is put together by the packager who makes this RPM, right? So Red Hat actually has a whole bunch of requirements in place for all of our RPM packagers, such that when they're producing a new version of the package, they're required to put in a changelog entry on why they're creating it. And some of the changelog entries are not very interesting. It's like first build of such package. That happens a lot when we're starting a new distribution. But then others, like we can see here on March 21st, 2022, that the packager included some code that resolved a CVE that was with Apache. And so as part of the standard Red Hat changelog requirements, he put in here the Bugzilla bug ID number. So if we went out to bugzilla.redhat.com, we could look up this number 2065250 and see the Bugzilla ID that goes with it. He included the CVE number. So if we went out to MITRE.org or the Red Hat security product security portal, we could plug that in and see what actual CVE and a description of the vulnerability. Also things like the grading, the CVSS score, or if there are any known exploits, like all that stuff is out in the product security portal. And then there's just a brief description of like what this is associated with, right? So that this is HTTP request smuggling vulnerability that was in this version of Apache earlier. This update, version 2.4.51-7, will close that CVE and that open Bugzilla.
And it wouldn't be a conversation about open source packaging without seeing Neil Gumpa's name in the change logs there. So shout out to Neil if you're watching this. Um, so like both of these names are people. Both the names on these change logs are people we know, people that have high standing within the community. But what if we wanted to verify that these people made actual supported changes, that this hasn't been tampered with? We know that within repositories that there's security that's built in. How can we use RPM to verify that these packages come from someone we trust?
So that's a great question, Eric. And before we get into the actual validation, I want to show you another RPM script. All right, so what we're looking at is the script for Cockpit WS, which is part of the selection of web console packages that allow you to use the web-based administrative UI for working with your system. And what I want to call your attention to is this right here. Actually, that we could probably take off the whole thing right here. And what I would like to draw your attention to is, what is this command?
Did we lose you, Scott?
No, I just turned off the camera for a second to re-trigger my motion-sensitive lights.
Oh.
Nobody needs to see me flailing around during the
No, that
episode.
would have been great. All right, so we're adding a user, Cockpit WS.
Yeah, and that reminds me, Eric, who can install software on a system?
Only someone with administrative access, so root or someone in the wheel group.
So one could surmise that by installing a piece of software, you're actually allowing someone to execute commands through the scripts with that software as root on your system. How do you feel about that, Eric? That you're letting like rando on the internet run programs on your system by installing their compiled package?
Well, I don't want them installing crypto miners and backdoor admin accounts when I go to install my HTTPD package.
Right. So most people don't realize, like, we talk about scripting and the fact that it makes our lives easier, but like really you're giving someone the ability to run arbitrary commands potentially on your system as root. So again, Eric was talking about like, how do we know that this comes from someone that we trust? And every package that we provide as part of Red Hat Enterprise Linux or the Red Hat family of distributions, right? So this goes with CentOS Stream and Fedora as well as Red Hat sponsored projects like the extra packages for Enterprise Linux repo. All of these packages that we help maintain, create, or provide standing to folks like Mr. Gampa have to be signed with a GPG key. And so we can take a look at what things we have installed, what keys we have installed, an RPMQ GPG dash pub key. And these are all of the GPG public keys that I have installed in my RPM keyring, meaning these are the ones that I trust packages from. And Eric, do you remember where we might have gotten these? Because I don't remember installing any of these.
I know a lot of times when we install like the Apple release package, or when we those keys are included in that package, but they're typically defined within the yum.repos.d configuration file. So, harkening back to when we manually configured a repo in episode 3, those are defined. We define a base URL, we give it a name, but we also say that we want to do a GPG check as well. And we can go out to the public sites where these repositories live and pull down those GPG keys and add them as a trusted package or as a trusted key to our keyring.
Yeah, and so here's an example that I pulled out of the Red Hat repo definition at yum.repos.d. So this GPG check value in your repo definition says I want to verify before I install the software that it is signed with one of my trusted keys. And then it also references a GPG key that is associated with this repo that I can import if it has not already been imported into my system. So this is where we get those. And occasionally you may have seen when you install something for the first time, it'll ask you about installing a GPG key. it's asking you if it's okay to import the key from this file. And in our previous episodes, we just used the -y option to DNF and Yum very liberally, which answers yes to all questions, including, yes, go ahead and import this GPG key. But that's how we got all of these keys imported into our keyring. And we can use RPM QI on one of them to get the information about it, including the actual key contents. But more importantly, in this top part, we get things like, what is it? Where did it come from? Whose key is this? And so you can see what keys came from where. And then if you have a package, so I actually downloaded this package earlier, and I got it from rpmfind.net. If you've not seen it before, rpmfind.net, you put in the name of a package and it shows you all the places where you can get it. And I just pulled one, and if I wanted to make sure that this is really Enterprise Linux 9, I can do an rpm-k to check the GPG key on this file. And we can see that this one reports as signatures not okay. And if we do a little bit of extra verbosity, it actually goes through and says things like, oh, we did a checksum and we're cool, right? Meaning we downloaded the file, and the downloaded file itself matches what's in the package metadata. But down here, where we're checking the GPG key, there's no key in our key ring that matches the key that was used to sign this package. So it tells me the key ID that was used, so I'd have to go out and find whose key this is. And then I could validate it if this is really from a trusted packager. But this GPG signature is how we keep you from masquerading packages being from someone that they're not really from. So the reason that we always keep GPG check enabled in our Yum repositories is to make sure that we're getting those pieces of software from our trusted sources. And if someone downloads something randomly to our machine, we would actually be kept from installing it with Yum or DNF because it doesn't have a matching GPG key.
Okay, awesome. So we're kind of we're just a little bit over time. Do you have any closing thoughts or any last examples you want to share?
I don't think there's anything else to share. I thought about doing RPM to CPIO, but that was like a bridge too far for today. So remember that there are also additional things that we've shown in DNF and Yum that we haven't seen yet on the program. Things like a reinstall, where we just like reinstall the package even though it's already installed. That can replace files that may have been deleted or modified in a weird way that you can't undo. So there's like a lot of different ways to do things in packaging. You could do it the Yum and DNF way, or you can get down in the weeds and do it the RPM way if you know the right options and arguments to pass to it.
And in fact, that was mentioned in chat was while DNF and Yum are by far, to be fair, superior utilities, it's good to be at least familiar with all of the tools in your tool belt, because you never know when something might corrupt DNF, and you might have to do a reinstall with a different package, you might have to do a reinstall with RPM. So being familiar at least with all the tools. When we were prepping for this episode, I'd forgotten most of the dash Q options, and so when we were prepping for this episode, I was having to go look at the man page to see, okay, what is Scott trying to do with this example? So it's good to be familiar, or at least to know that these things are available and you can use them as part of your toolbox when it comes to managing Linux systems. So as you might have noticed in this episode, we got a little bit deeper into the weeds than we have been as of late, and in fact, we're going to be doing. I won't call it I won't call it a story arc or anything so dramatic, but we'll be doing a series of episodes coming up where we take some of the early topics that we covered, things like package management, and we're going to dive in just a little bit deeper. We're going to go to that next layer. And next week's episode will be the same. We talked about file management early on in the show, and so we're going to talk about some of the special permissions, things like sticky bits and set UIDs, or managing files with ACLs. So if you want to get a little bit deeper, do address a little bit more unique use cases with file management, definitely catch us next week at our new time. It was great to see a lot of activity in the chat today. There's a bunch of our folks that hung out and were chatting back and forth. So I'd like to say that early signs say that the new time and date are going to work out well. So be sure to tell a friend. We're pretty excited about hanging out at lunchtime on Fridays to talk about terminal-y things. So definitely like this content. That helps raise it up in the YouTube algorithm. And hopefully Skynet is watching these episodes. Definitely share the content, comment with us in each episode if you have any questions. We're usually pretty active about getting back to those. So meantime, on behalf of Scott McBrien, myself, and the entire Red Hat Enterprise Linux team, we will see you next Friday at 12 p.m. Eastern, and we'll be talking about file permissions. Until then, thank you so much.
Bye, everybody.